Good afternoon to everyone. Now, you know that I am discussing the hydrogen. It is a part of the second volume, first unit of the second volume, right? Yes, good afternoon. So, come to the context. That is, today I will discuss on the compounds of hydrogen. Compounds of hydrogen. What is the general name of these? These are called hydrides. These are hydrides, correct? So, the compounds of hydrogen is hydrides. Now, types. Types, that is ionic or ionic hydride, covalent hydride and interstitial hydride. First one is ionic hydride, next covalent hydride and interstitial hydride. Now, ionic hydride is another name, is called as saline hydride. Okay. So, what are the compounds or what are the elements which form ionic hydrides? It is also called saline hydrides. Or now, these two are stoichiometric hydride. And this is non-stoichiometric. So, what is stoichiometry? That means when, suppose, just come with an example in NH3. NH3, here number of nitrogen atom is 1, nitrogen 1 and hydrogen is 3. So, these are whole numbers. So, these are whole numbers. So, when a compound is formed, when the atoms are joined in whole number, then it is called stoichiometric compounds. In these two are stoichiometric ratio is maintained, but in interstitial hydride it is non-stoichiometric in nature. Okay. So, non-stoichiometric means, one example of non-stoichiometric is that cesium hydride 2.7, cesium hydride 2.7, cesium hydride 2.7. Now, this number is fraction, and for this reason it is called non-stoichiometric. Okay. So, first of all, types of hydride: ionic or salt-like, saline hydride, covalent hydride and interstitial hydride. Okay. Next, I have to move to the ionic hydrides. Now, ionic hydrides are made by the elements of group 1 and 2, that is alkali metal and alkaline earth metal. Alkali metal and alkaline earth metal forms ionic hydride. Covalent hydride, it is formed from group 13 to 17. And interstitial hydrides, these are formed by D block elements. D block elements. Okay, and also by some metals. D block elements and also metals. Okay. So, ionic hydrides are made by group 1 and group 2. Covalent hydride group 13 to group 17. Next one, non-stoichiometric, it is formed by the D block elements. Okay. Now, coming to the in details of the ionic hydride. Why this is called ionic hydride? Ionic hydride. The example of such kind is that sodium hydride, potassium hydride, calcium hydride, etc. These are the examples of ionic hydride. Now next point is that what is the here you can see that hydrogen, here the oxidation state of hydrogen is -1, because as sodium or calcium is more electropositive than hydrogen, so here hydrogen can work as a the negative part. Okay. So when it is electrolyzed, that is NaH is electrolyzed, it forms Na plus plus H minus. Na plus will move towards cation, will move towards cathode forming Na, and H minus will form hydrogen on the anode. So this is the electrolysis of the hydride, that is ionic hydride. Next one, another one example, that is lithium hydride. Okay. Now there are two compounds, that is lithium aluminium hydride, lithium LiAlH4 and lithium borohydride LiBH4. So these are the two important reducing agents, strong reducing agent. LiLH4 is more stronger reducing agent. And how this is formed? When lithium hydride reacts with aluminium chloride, that is dimer of aluminium chloride. Lithium hydride reacts with dimer of LCl3, then it forms lithium aluminium hydride and 6LiCl plus LiCl. Okay. And when the next one at this lithium hydride, when it reacts with diboron B2H6, then it forms LiBH4. So it is at the same time, it is the preparation of LiLH4 lithium aluminium hydride. The name of this compound is lithium aluminium hydride and lithium borohydride. And another one is that sodium borohydride is also there. There you should take NaH in place of LiH. This is called lithium borohydride. Borohydride. Clear? So these are also hydride. Just follow the last word, it is also hydride. So these are very important compounds. This is used in the reducing agent, works as a reducing agent, okay, in organic compound, in organic chemistry. Okay, this is about ionic hydride. Next one, that is covalent hydride. Now just take from group 13. Now the group 13 elements, that is boron BH3, okay, LH3, but BH3 does not form in monomer, it forms in dimer. B2H6 is more stable because in BH3 the valency is not satisfied. For this reason it makes a B2H6 by forming a banana bond. It is the structure of B2H6. Okay, so it is the one hydride that is formed by group 13 elements, and these hydrides are electron deficient. These are electron deficient. Next one, that is group 14, that is CH4. CH4, SiH4, these are group 14 hydrides. Silicon hydride, carbon hydride, or this general name is that methane, it is silane. Okay. So these are the compounds or hydrides of group 14 elements. Next one is generally they are from covalent bonding. Covalent bonding. Next group 15 NH3 CH3. These are electron donors. Electron donor or electron rich species. Next one, next is group 16, that is H2O, H2S. These are from group 16. These are also electron donors because the lone electron pair is there in the nitrogen head, phosphorus head, the head of oxygen, and also in the head of sulfur. So it is also electron donor. Okay, so one is electron deficient, next one electron donor, and these are covalent bonding. Now the compounds like C2H2, C2H4 in this group, C2H2, C2H4, they are also electron precise compound, electron precise compounds. Okay. So these are the types of covalent hydride. One is electron deficient, one is electron rich, another one is electron precise. Clear? Up to this clear. Next I will move to the next part, that is the non-stoichiometric compounds or the interstitial hydrides. Interstitial hydrides. Okay. So interstitial hydrides is formed by the metal which having void spaces, in their crystal lattice, So void spaces in their crystal lattice, and as the size of the hydrogen is very small, so it can easily trap in these void spaces. It can easily trap. Suppose these are the, suppose I am drawing an now this is the void space. It is also called octahedral hole. Okay, because there are 6 atoms are there. So in this space it is very small inside, but which fits in the side. But as hydrogen is very small inside, it can easily fit in that side. For this reason, it is called the interstitial hydrides, and it can place in the void spaces in the crystal lattice. What is crystal lattice? It is the arrangement of the metal in the crystal, arrangement of metal atom in its structure or in its crystal. It is called crystal lattice. Okay. Now in void spaces, when these small atoms can be placed or can take place, then the ratio, that is they are formed non-stoichiometric hydrides. The non-stoichiometric hydrides, it is not that the atoms are divided. It is that in a volume, what is the number of moles or number of hydrogen atoms are there, and if we make a ratio of that, that means per metal atom, the number of hydrogen atom, that means average number of hydrogen atom when we calculate, then it becomes a fraction. Okay, so it is from the volume quantity, that means number or moles of hydrogen atom can be trapped in these void spaces in a definite volume of metal atom. Then when we are calculating the average volume or average number of hydrogen atom, then it becomes fraction. And I have told you one example of that, that is cesium hydride 2.2, lithium hydride 2, lanthanum hydride 2.1, cesium hydride 2.7. So this is an average. Okay, so that's all from the hydride, that is ionic hydride, covalent hydride and interstitial hydride. Okay, so from here a short note will come, may come, that is what is ionic hydride, okay, what is called covalent hydride, and you may also be answered that give a short note on the hydrides. Clear? Is it clear up to this? Is it clear, Sohani? Next I will move to the next topic. Okay, so next topic is that I have told you about the water in the last class, that is about the hybridization of the oxygen atom in water molecule and also some physical characteristics of water molecule, that is its refractive index, water conductivity, conduction towards the heat, and also the surface tension are higher, and what are the special properties, that is the polarity and hydrogen bonding is responsible for that property. Now after that it comes to the next point, that is chemical properties of water. Chemical properties of water. So one is that amphoteric behavior. Amphoteric behavior. Now amphoteric behavior, that means at the same time water can act as acid as well as base. It is according to the concept of Bronsted-Lowry. It is according to the concept of Bronsted-Lowry, and from this water is amphoteric in nature. Now we will follow two examples with respect to that. HNO3 aqueous plus water or H2O, it produces H3O plus NO3 minus. Okay, now in this example follow that water takes up the proton which is released by the HNO3. So as it is taking up the proton, it is works as a base, because from the Bronsted concept, when a species takes up the proton, then it is called a base. Okay, and in another example, that is NH3 plus H2O, it's forming NH4 plus and OH minus. Now follow here, H2O releases H plus, which is takes up by NH3. So here H2O as an acid. Okay, so by these two examples we can tell that H2O can works as an acid and also as a base. Clear? Is it clear? Okay. So next is that what is auto dissociation? The auto dissociation is that when two molecules of water is there, then it is assumed that they are in equilibrium. Equilibrium with respect to the equation, that is equilibrium with respect to that equation, that is H2O plus H2O forming the equilibrium sign H3O plus OH minus. Okay, now this sign is the sign of equilibrium. This sign is the sign of equilibrium. Okay, now this sign is the two molecules, one molecule takes up the proton and another one releasing that proton. It is called auto dissociation. Auto dissociation. Okay, this is auto dissociation. Next reaction of water is that as an oxidizing and reducing agent. Water as an oxidizing agent and as a reducing agent. Water as oxidizing agent. So, when water will act as an oxidizing agent, then it will react with an electropositive element, that is, suppose Na plus H2O, forming NaOH. We know the reaction, plus hydrogen. Now from here to there it is the reduction. So here H2O is an oxidizing agent, and water as reducing agent. Water as reducing agent, when H fluorine is there, F2 plus H2O. Here the product is HF plus O2. Follow it, it is the oxidation, so the H2O is reducing agent. Okay, so by these two examples we can tell that water can work as an oxidizing agent and also as a reducing agent. Okay, so today up to this only. Have you any confusion? Okay, thank you everyone. Next day I will start from the hydrolysis reaction, that is the hydrolytic reaction. Thank you everyone.